Hi everyone, as promised, we're going to plot each complex number in the complex plane and write it in polar form, and we're going to go ahead and express the argument in degrees. So basically remember, polar form for the complex plane is r, or z, equals r times cosine of theta plus I times sine of theta, and we discussed this in a previous video. So basically here is our form, our x. This has the form x plus yi, which is like that. Okay, so the first thing we want to do is find the r, and then we need to find our angle. So r equals square root of x squared plus y squared. So this is going to be negative 1 squared, plus 1 squared, which equals the square root of 2. Alright, and then for our angle, what I like to do is go ahead and kind of graph this, try to write this as straight as I can. So, and I should have did this on the line, but anyway, so negative 1 on the x and 1 on the y. So there's your point, and this r, which is the distance from the origin, is the square root of 2. This is your imaginary axis. This is your real axis. Okay, so there it is. We know this is in quadrant 3. And we actually know this is like a 45-degree angle. We're going to go ahead and use tan. I already know this is going to be 135 because it's a 45-degree angle here, if I drew the graph better. So we get y is 1 over negative 1. So we have tan of theta equals negative 1. And theta in quadrant, oh, why did I put 3? It's quadrant 2. I know I could hear y'all telling me that. Okay, so tan of theta equals negative 1, so that's in quadrant 2, so that means my angle is 135. And we're going to express this in degrees, so we're basically done. R square root of 2 times cosine of 135 plus I times sine 135. So this is different. Before, when we were expressing this, we had our r was square root of 2, and then we had our angle this was polar form, but this was not in the complex plane. So now we are writing our equation in the complex plane. Okay, we can go a little faster. Our x basically is 1. Our y is negative square root of 3. So I'm going to find r, and r is going to be the square root of 1 squared plus negative square root of 3 squared. That's going to be square root of 4, which is 2. So my r is 2. And now I'm going to go ahead and plot this somewhere just to see where we're at. Or you can kind of do this without even looking. So my x is 1, and my y is negative square root of 3, which is close to square root of negative 4, or negative 2, because square root of 4 is negative 2. So basically here it is, and this length here is 2. We know we're here in quadrant 4, so whatever angle I find for tan, we're in quadrant 4. So tan of theta equals y over x. So this is negative square root of 3. So that means my angle is going to be 300 degrees. Whoops, why did I put 330? 300 degrees. Now, we're just going to write our polar form equation. So we get 2 times cosine of 300 plus I times sine of 300 degrees. And remember, this is I, R. I tend to forget some of this. All right. Now this one we just have a negative 2. So basically if you want to write this as really negative 2 plus 0i. So my x is negative 2 and my y is 0. I'm going to go ahead and kind of plot this. So we're going to do this. My x is negative 2. So there it is. And you can already tell right away what the radius is. The radius is going to be 2 here. Okay, but let's go ahead and do it. R equals the square root of negative 2 squared plus 0 squared. So this is going to be square root of 4, which equals 2. We already knew that. We can see the radius right there. Now for tangent, can you already tell where we're at? So this is imaginary, real. If you look at this angle here, we're at pi, or 180. We're supposed to do it in degrees. So let's just go ahead and set it up though. This is tan equals 0 over negative 2, which equals 0. So tan is 0 at pi, or 180, sorry. So we're going to write z equals 2 times cosine of 180 degrees plus I times sine of 180 degrees. Right, we're going to do, I think, 3 more. This one's a little bigger numbers here, so a little harder to graph for me anyway. I think I already did it, so let me find it. Okay, I already did it here. And I know my x equals, here we are. My x equals 9 square root of 3. My y equals 9. So I'm going to go ahead and try to graph this a little bit. Now, just going to estimate this. So I have 9 is my x. And, okay, so 9 is my y. I'll put 9 here on the 3. And 9 square root of 3 is very close to 18. So I'll put 18 here, but not quite. So here it is. Actually, this line should be brought down a little bit because it's not very proportional. So anyway, somewhere around here. And there's your radius part there. All right, so here we go. We need to find our r, the length of this. So we're going to get r equals square root of 9 square root of 3 squared plus 9 squared. This equals, let's see, square root of 324, which is 18. Okay, and so then we have, we need to find our angle. So tan of theta equals y, which is 9 over 9 square root of 3, which is 1 over square root of 3, which equals square root of 3 over 3. So that means my angle is 30 degrees. We're in quadrant 1 here. This is your imaginary. This is your real axis here. So this is 30 degrees. And we're just going to write this out as z equals 18 times cosine of 30 plus, so this is 18 here, plus I sine of 30. All right, the next one we have is this one. So my x is 2, my y is 3. I'm going to find my, oh, this is easy to graph, isn't it? So let me graph this one. Okay, so this is imaginary axis, real. So we're going over 2, up 3. And we need to find r, which is this length here. Okay, so this is z equals 2 plus 3i. Excuse me. So r equals the square root of 2 squared plus 3 squared, which is going to be, let me see, is this supposed to be square root? Let me see what I did real quick. Actually, guys, I kind of made a mistake because I did these on a sheet of paper before I did the video. This should be square root of 3. So sorry about that. So square root of 3 is not up to 3. Square root of 3 would be, sorry, right below the 2 here. So we're going over 2 and up to about here. So it's right here. Right about there. See if I can write this without erasing the other piece. Nope. Alright. Anyway, sorry for the delay. But anyway, I wrote the wrong problem down. Trying to get ahead, do well by writing it down, and then I mess up. So this is square root of 3 squared. So you're going to get the square root of 7. And that's your r. So this is the square root of 7. And this point here is that equation. And that's square root of 3 again. Alright, sorry about that. Now let's do your tan function. And we get y over x. So my angle is square root of 3 over 2. If you inverse that, you're going to get your angle is 40.9 degrees. And after that, it's just easy to fill everything in. So z equals square root of 7 times cosine of 40.9 degrees plus I times sine of 40.9 degrees. Okay, we have one more. And let me see if I wrote it down right. Yes, okay. So basically, let me graph it, look what it looks like on the graph. All right. So square root of 5 is a little bigger than 2. So I'll put that here. And then we're going down 1, so it's right here. And that's your z point here. This is your z. And we're going to find the r here, the length of the from the origin to my z. So we're going to find r is the square root of 5 squared plus negative 1 squared. And that's going to give us the square root of 6. So this length here is square root of 6. Now we're going to do tan of theta equals y over x, which equals negative square root of 5 over 5. We are in quadrant 4 here. So basically, I'm going to inverse this. And you get your angle equals approximately 335.9 degrees. And when you write this down, you get C equals R times cosine of 335.9 degrees plus I times sine of, why do I always not leave room? 333.9 degrees. Okay, so that's it. The next video is going to be doing the opposite. We get the equation in polar form, and we're going to write it in rectangular form. Thank you and have a nice day. Bye-bye.